Welcome Primary 5, Miss Hiba Ahmed is with you. Today we will take part 2 from Lesson 3, which is called Magnetism. In the part 1 we take the history of discovering the magnet and the types of the magnet and the types of the materials according their ability to attract it to the magnet. Today we will take the properties of the magnet. Okay, the magnet has many properties. As you can see, this is the shape of the magnet. The two ends of the magnet we called it poles. Okay, so that's the south pole and that's the north pole. So the end of the magnet we called it poles. So the magnet has two poles, south pole and north pole. Okay, the south pole will be in blue color and the north pole will be in a red color. Okay, okay. So the two ends of the magnet are called, very good, poles. And the magnet has how many poles? 3 poles? No, the magnet has 2 poles. Okay, if I have a magnet in my hand and I put near to the magnet some paper clips which is made of steel. The paper clips which is made of steel, it's a magnetic or a non-magnetic material? Very good, it's a magnetic material, so it will be attracted to the magnet. Very good. Okay, if I have some paper clips and I have the magnet and I put the magnet near to the paper clips, what will happen? I can see that the paper clips attracted only to the 2 poles of the magnet. Okay, as you can see in this picture, okay, the paper clips attracted to only the 2 poles. Okay, so the most attraction force of the magnet is concentrated in the 2 poles. What is the meaning of concentrated? Is exist. Okay, exist in a lot. Okay, so the 2 poles, okay, it's a place in the magnet in which the most magnetic power is concentrated, and the proof of that the magnetic materials attracted to the 2 poles of the magnet, as you can see. So the property number 1, magnet has 2 poles, and we must know that the most attraction force is concentrated in the 2 poles. Okay, give reason for when you approach a magnet to some iron nails, the most of them attracted to the 2 poles of the magnet. Why? Very good, because the attraction force of the magnet is concentrated at the 2 poles. Very good. So we finished the property number 1. Property number 2. If I have a magnet and I suspend the magnet, as you can see in this picture, okay, the magnet will take a fixed direction. It will take a fixed direction, which is north south. This pole of the magnet is pointed to the north direction. You know the 4 direction: north, south, east, west from the social. Okay, so when we suspend the magnet freely, as you can see in this picture, the magnet will take a fixed direction, which is north south. The north pole will point it to the north and the south pole will point it to the south direction. So it's a very important question. When we suspended the magnet freely, it will take fixed direction, which is north-south, So the magnet has 2 poles. Excellent. And the most attraction force is concentrated in the 2 poles. And when we suspend the magnet will take fixed direction, which is very good, north-south. So we finished the first 2 properties of the magnet. We will take now the third property. I have here, as you can see in this picture, 4 magnets. Okay, the first 2 magnets, that's the south pole and that's the south pole. So the poles here is like each other. Okay, and here we have here in this one, this is the north pole and this is the south pole. Okay, and here they are different poles. Okay, what will happen if you put different poles of 2 magnets near each other? They will attract each other. So different poles attract each other. The north pole will attract the south pole. Okay, the attraction force will be in this direction, as you can see the arcs. Okay, But if the poles are like each other, like this one, here you put a magnet, the south pole of a magnet near to the south pole of another magnet. What will happen? They will repel. Okay, they will repel in different direction, as you can see. So like poles attract, different poles repel. Like poles attract, different poles repel. And here, if I have two magnets, one it's a north pole here, and I put the north pole of another magnet beside it, what will happen? They will repel each other. So like poles attract, okay, but different poles repel. Repel meaning go in different direction, okay, but attract meaning go in the same direction and attract each other. Okay, so the magnet has two poles. The most attraction force is concentrated in the two poles. When we suspend the magnet, it will take fixed direction, which is north-south. The like poles, very good, repel. The different poles attract. Like poles or similar poles. Okay, like means similar. Okay. Here, can you answer this question? Okay, here we have like or different poles. Very good. We have north and south, so they are different poles. They will attract or repel. Very good. They will attract. But here we have south pole here and south pole here, so they are like poles. They will attract or repel. Very good. They will repel each other. Here we are suspending the magnet. It will take fixed direction, which is here it's the north and south. Very good. Okay. The fourth property of the magnet, it's the magnetic field. Okay. If I have a magnet and I have here iron filings, it's a substance that we can see in the lab, inshallah. Okay, iron filings, it's a small pieces of iron. Okay, and iron, it's a magnetic material, so it will be attracted to the magnet. Okay, if I have here a magnet and I put a lot of iron filings around it, what will happen? It will take this shape, as you can see. Okay, this shape is called the magnetic field. What is the meaning of the magnetic field? It's the space around the magnet in which the magnet can attract the magnetic material. Okay, if I have here the magnet, okay, and I have here a nail, and I put the nail here, it will attract it to the magnet? Yes. I put the nail here, will attract it to the magnet? Yes. If I put the nail here, it will attract it to the magnet? No. Why? Because the force of the magnet has a field, okay, has an area, okay. If the magnetic material inside the magnetic field or inside this area, it will attract it to the magnet. If the magnetic material is outside the magnetic field, it will not attract it to the magnet. So the space around the magnet in which the effect of the magnetic force appears, or in which the magnet can attract the magnetic material, it's called a magnetic field. So now we finished the properties of the magnet. Magnet has two poles. When we suspend the magnet, it takes fixed direction, which is very good, north, south. Like poles, attract or repel? Repel. Different poles attract each other, and we take the magnetic field. The magnetic force is cancelled. Okay. Okay. Let's now know the uses of the magnet. We discovered the magnet, and we know that there is a natural and we made the artificial magnet. Why? Because we need to use the magnet to make our life easily. Okay, so we use the magnet to make the compass. Do you know what is this? That's the compass. Okay, the sailors, okay, when they are sailing in the sea, they need to know the direction, the north, the south, the east, the west. They use what? They use the compass. So the compass, it's a tool, which help us to identify the main four direction, which is north, south, east, west. Okay? Okay, this compass is consists of needle magnet. Can you see? That's a needle magnet. This one is a needle magnet. So we use the magnet to make the compass, and we use the compass to identify the main four directions. And you must know that we use the needle magnet. Okay, he will ask you which type of magnet that is used in the compass. It will be the needle magnet. Thank you for listening. We finished now lesson 3. Thank you. Miss Ahmed was with you.